So today we're going to find the names of angles cut by a transversal. So when you have lines cut by a transversal, basically the diagram kind of looks like this. You start with two lines, and then the transversal is a line that cuts through both of those. So something like that, for example. So here's your transversal, and then there's the two lines. So it is helpful to know a little bit of terminology before we get into these things. So alternate means on different sides of the transversal, so like one angle on the left, one angle on the right. Interior are all the angles inside these two lines. And exterior means outside the lines, so these angles and these angles. So interior, exterior. Okay, so now you should definitely take notes on this because these are going to be very important. I'm only going to draw one example of each of these because if you draw all the examples, it's going to get very busy and cluttered. Like, for example, vertical angles we talked about yesterday. These are vertical angles, but so are these. But so are these. And, you'll just have a bunch of marks all over your paper, and it doesn't seem worth it. And obviously, it would just confuse you. So we're going to draw one example of these on there. So let's start with linear pairs. Linear pairs are adjacent angles that are supplementary and they form a line. So you can pick tons of examples. I'm going to go with this one right here. That angle and that angle. And I used different numbers of arcs on this. I used one arc here and two arcs on this angle because if these lines are parallel, which they sure look parallel, but we don't have any diagrams to designate that, these are not going to be the same thing, unless, of course, it's 90 degrees and 90 degrees, but then the transversal would be perpendicular to these. We don't have that right now. So vertical angles. Vertical angles, we already gave a pair. We'll do that same one. Boom, boom. And you should be copying these diagrams because it's just like the important thing here is being able to recognize which angle pairs are being formed. So vertical angles, they're across from each other when you have intersecting lines. So like those two, also these two, those two, and those two. All examples of vertical angles. And we know that vertical angles, no matter what, are always congruent to each other. That's why I used one arc, one arc. All right, now these. This is where we start to see alternate and interior and exterior and stuff like that, like the slide we looked at before. And now I'm going to mark these the same way with the one arc, two arc thing, if they're congruent or not congruent. But that's only if these lines are parallel, and we're going to talk more about that in the next lesson. So, alternate interior angles. First off, they're on the interior, so they have to be in here. And alternate means one on the left, one on the right. So for example, you could look at this angle right here and this angle. They're both interior, and one's on the left, one's on the right. However, if you look at that and that, that's just a linear pair because it makes this line. So what you really kind of want is one angle on one transversal, so like here, and one angle on the other transversal. Alternate interior angles come up a lot, and I like to think of it, look for the Z form here. They make kind of a Z shape when you connect the two angles, and those are going to be congruent when the lines are parallel. Now, alternate exterior are going to look similar to that. Same idea, except they're going to be on the outside. So instead of in here, we're looking up here and down here. So here's an example of alternate exterior. We have this angle on the left and this angle on the right. And yes, those are congruent as well when the lines are parallel. Now, same side interior angles. These are pretty easy to figure out because they have to be on the inside and they both have to be on the same side. So like both on the right, both on the left. I'll do the right. So we have this angle here and the other angle on the right in the interior is right here. And you can see just looking at these, if the lines are parallel, that this looks like an obtuse angle, this is acute. They can't be congruent to each other. Now, corresponding angles get a little weird because corresponding, that doesn't say alternate, exterior, interior. You can't figure it out on your own. So corresponding are same side, and you have one exterior, one interior. So it's a little confusing, but they come up a lot too. So for example, if we do this angle right here, the angle that corresponds to it is this angle down here. So if you see, they're both on the right side of the transversal, and then one's on the interior, one's on the exterior. Again, the important part about today is just being able to recognize these and name them. So if you see a pair of angles that look like this, you should be able to say, oh, those are alternate interior.